Hello everyone. Today we will be discussing the midterm examination of Theory of Automata and Computation as in the semester 2022 October. So here we are asked to solve 5 questions. The first question here is construct a finite state machine with minimum number of states accepting all strings such that the number of A's is divisible by 2 and the number of B's is divisible by 3. Here what you need to do is you have to construct a DFA for input alphabets A and B. And the number of A's is always divisible by 2. It means the number of A's are always even. It can be 0, 2, 4, 6, 8. In this way the number of A's should be even. And here there is a condition on B's that the number of B's should be divisible by 3. Again, it can be 0, 3, 6, 9, 12 like that. So we have to, just add these two conditions and we have to make a final DFA. So for that, first of all, I would suggest you to write the strings which are accepted by this DFA and accordingly you have to draw the DFA. After drawing the DFA, just verify that the given strings are accepted by the DFA and any wrong string is not accepted by the DFA. In this way, you can verify it. And this is of 2 marks because it's a very, easy question. Now coming to the next question here, this particular table is given and this table is of NFA because you can see that here A is reaching on 2 states on input alphabet A and similarly D is not reaching anywhere on input A and B, and this is not capital B but this is small b. So here the input alphabets are A and B and the states are A, B, C, D. Initial state is A and final state is C. So you have to solve this and you have to convert this NFA to DFA finally by applying the algorithm that you have learned in the class. This is of 3 marks. Next, the third question is design a DFA over input alphabet this 0 and 1 where the given language is this. So how you need to solve it is, first of all, you are given that I and J is greater than equal to 1. So initially you can take I is equal to 1 and J is equal to 1. Accordingly, you can form one string. Then you can change the values of I and J respectively. Like I can be 2 and J can be 1. Then I can be 1 and J can be 2. And similarly, I can be 2 and J can be 2. In this way, you will form different strings of different length. So after, writing 6 to 7 strings, you will generalize a behavior of the strings. And accordingly, you have to again draw a DFA. And whatever strings initially you have produced with this language, you can verify it after the DFA has been constructed. So again, this question is of 3 marks. Then the next question is find the reduced DFA for the given DFA. So means there are so many states in this given DFA. So there are around, 8 states in this DFA. And what you have to do is you have to reduce it. So it can be reduced to lesser number of states by applying the reduction algorithm. So here what you can do is you have to first of all, remove those states which are unreachable. And then you have to apply the algorithm. As you can see in this example, this Q4, Q7 state is never reachable, right? After reaching to the final state Q3, you cannot ever reach to Q4, Q7, Q6 and Q5. So these 4 states are never reachable, right? You cannot reach them. So these are unreachable states. So first of all, you will remove these. After removing it, you will find that we are left with only 4 states. So it means out of 8 states, we have removed the 4 states. Now we are left with the 4 states and you will apply the reduction algorithm on the 4 states and then you will find out whether it can be further reduced to lesser number of states. Initially, now we are having 4 and whether we have to verify it can be reduced to 4 or it can be 4 also. So this question is of 3 marks. You need to solve it and you have to see that once you have made the reduced DFA, the behavior of the reduced DFA should be same as of the original DFA. Means it should accept the same number of strings. Now coming to the 5th question in this sessional paper or midterm examination, this question is of highest marks. What you need to do is here you are given a regular expression, right? So this is a regular expression. This is actually 0 closure 1 and whole closure, then union 1 closure 0 and whole closure. What you need to do is first of all you have to draw a non-deterministic finite automata with epsilon moves, right? After that you have to actually find out all the possible strings which are accepted by this. You can find out all the strings of length 0, 1, 2, 3, 4 and then you can generalize the string behaviors and accordingly you have to write the reduced regular expression for this and then finally you will draw the reduced finite automata. So this was the midterm sessional which was having are 15. right? So the thing is, this is the question paper. In the next video, we will discuss the solution of this paper.